The recent earthquakes that hit southern Turkey and northern Syria have caused immense damage and loss of life. With over 5,000 fatalities and tens of thousands of people injured, the situation is dire and requires immediate attention. In response, the United Nations has called for an international response, and world leaders have pledged to provide aid. I am making this informative video on earthquakes to raise awareness about the devastating consequences of these natural disasters and to highlight the ongoing efforts to provide support to those affected. It is important to understand the impact earthquakes can have and the importance of preparedness in order to minimize loss of life and property. The footage of people digging through the rubble with their bare hands in search of survivors is a powerful reminder of the urgency of the situation and the need for immediate action. The earthquakes have also revealed the challenges faced by rescue teams in the aftermath of such disasters. With freezing temperatures, darkness, and rain hampering their efforts, the full extent of the destruction may take days or even weeks to determine. The international community's offer of aid from over 45 countries, including NATO and the European Union, demonstrates the importance of solidarity and cooperation in times of crisis. This video aims to inform and educate the public about earthquakes and their devastating impact, as well as to raise awareness about the ongoing efforts to provide aid and support to those affected. Earthquakes are one of the most powerful and devastating natural disasters in the world. They occur suddenly and can cause widespread damage to communities, infrastructure, and the environment. Understanding earthquakes is crucial in order to prepare for and respond to them effectively. In this video, we will explore the science of earthquakes, including their causes, the methods for predicting them, and the impacts they have on communities. Every year, millions of people around the world are affected by earthquakes, and the damages can be substantial. On March 11, 2011, a 9.0 magnitude earthquake struck the Pacific coast of Japan, causing a massive tsunami and widespread damage. The earthquake and tsunami claimed over 18,000 lives and resulted in widespread damage to the region's infrastructure. The estimated cost of the disaster was over $300 billion, making it the most expensive natural disaster in history. The causes of earthquakes are complex and varied, but the most common explanation is plate tectonics. The Earth's outer shell is divided into several large plates that move and interact with each other, causing stress to build up. When the stress becomes too great, it is released in the form of an earthquake. Human activities, such as large-scale construction and the pumping of water from underground aquifers, can also trigger earthquakes. In recent years, there have been significant advances in the science of predicting earthquakes. Currently, scientists use a combination of seismic monitoring, computer models, and historical data to make predictions. However, predicting earthquakes remains an inexact science, and many experts believe that there is still much to be learned about this complex phenomenon. There are even speculations that in the future, it may be possible to predict earthquakes with greater accuracy and even provide early warning systems to communities. Despite the limitations of current earthquake prediction methods, understanding seismic waves is crucial for measuring the magnitude and intensity of earthquakes. There are several types of seismic waves, including P waves, S waves, and surface waves, each with unique characteristics and impacts on the ground. By studying these waves, scientists can determine the location, size, and strength of an earthquake, which is critical information for first responders and relief organizations. In the coming sections, we will delve deeper into the science of earthquakes, exploring the damage they cause, the methods for preparing for them, and the famous earthquakes that have shaped history. So, sit back and get ready to learn about one of the most powerful and fascinating natural phenomena on Earth. Causes of earthquakes. One of the most fundamental aspects of understanding earthquakes is identifying their causes. Earthquakes can be caused by a variety of factors, but the most common explanation is plate tectonics. Plate tectonics is the theory that the Earth's outer shell is divided into several large plates that move and interact with each other. These plates are constantly in motion and can cause stress to build up along their boundaries. The Earth's plates are constantly moving and colliding, and when the stress along their boundaries becomes too great, it is released in the form of an earthquake. The most well-known type of plate boundary is the San Andreas Fault in California, which is a boundary between the North American Plate and the Pacific Plate. The San Andreas Fault has caused several large earthquakes in California's history, including the 1906 San Francisco earthquake, which had a magnitude of 7.9 and claimed over 3,000 lives. In addition to plate tectonics, human activities can also trigger earthquakes. For example, large-scale construction projects, such as dam building, can cause earthquakes by altering the Earth's natural stress patterns. The use of underground nuclear explosions for military or other purposes can also trigger earthquakes. Another example is the pumping of water from underground aquifers, which can cause the ground to sink and trigger earthquakes. The increased frequency and severity of earthquakes in some areas are also believed to be related to the extraction of oil and natural gas from underground reservoirs. In Oklahoma, for example, the number of earthquakes with a magnitude of 3.0 or greater has increased dramatically since 2009, coinciding with a significant increase in oil and gas production in the state. Despite the various causes of earthquakes, it is still not possible to predict them with absolute certainty. Scientists can use a combination of seismic monitoring, computer models, and historical data to make predictions, but earthquakes remain one of the most unpredictable and dangerous natural disasters. In the coming sections, we will delve deeper into the science of predicting earthquakes and explore the current methods used to make these predictions. The science of predicting earthquakes. One of the biggest challenges in the field of earthquakes is predicting when and where they will occur. Despite advances in seismic monitoring, computer modeling, and historical data, earthquake prediction remains an inexact science. However, understanding the science behind earthquake prediction is crucial for reducing the impacts of these disasters. The first step in predicting earthquakes is to monitor seismic activity, or the movement of the Earth's crust. Seismic monitoring is done using a network of seismographs, or instruments that measure ground motion, located throughout the world. These instruments can detect even the smallest earthquakes and provide critical information on their location, size, and magnitude. This information is used to create models of the Earth's crust, which can help scientists identify areas where earthquakes are likely to occur. In addition to seismic monitoring, computer modeling is also an important tool in earthquake prediction. Scientists use computer models to simulate the behavior of the Earth's crust, including how it reacts to stress and how it moves during an earthquake. By analyzing these simulations, scientists can make predictions about the size and location of future earthquakes. However, despite these advances, it is still not possible to predict earthquakes with absolute certainty. There are many factors that can affect the likelihood of an earthquake, including the size and location of the plates, the strength of the Earth's crust, and the amount of stress that has built up. This complexity makes it difficult to determine when and where an earthquake will occur. In recent years, there have been several high-profile cases of failed earthquake predictions, which have raised questions about the accuracy and reliability of these methods. For example, in 1975, the Chinese government announced a prediction of a massive earthquake in the city of Haicheng, which failed to materialize. In 2011, the Japanese government also failed to accurately predict the massive 9.0 magnitude earthquake that struck the Pacific coast of Japan. Despite these limitations, the science of predicting earthquakes is constantly evolving and improving. There are even speculations that in the future, it may be possible to predict earthquakes with greater accuracy and even provide early warning systems to communities. For example, in Mexico, a network of sensors and alarms has been installed in high-risk areas to provide an early warning of an impending earthquake. Understanding seismic waves. Seismic waves are the waves of energy that travel through the Earth's crust during an earthquake. These waves are responsible for the shaking and damage that occurs during an earthquake. Understanding seismic waves is crucial for understanding the behavior of earthquakes and their impacts on the environment. Seismic waves are divided into two main types, body waves and surface waves. Body waves are the faster and more energetic of the two and travel through the Earth's interior. The two main types of body waves are P waves, primary waves, and S waves, secondary waves. P waves are the first to arrive at a seismic station and travel through the Earth's crust by compressing and expanding the material they pass through. S waves are slower than P waves and cause the ground to shake side to side. Surface waves are slower and less energetic than body waves and travel along the Earth's surface. The two main types of surface waves are love waves and Rayleigh waves. Love waves cause the ground to move horizontally, while Rayleigh waves cause the ground to move in a rolling motion. These waves are responsible for much of the damage that occurs during earthquakes, as they can cause buildings and structures to shake for longer periods of time than body waves. The energy that seismic waves carry can also be used to study the Earth's interior. By analyzing the behavior of seismic waves, scientists can learn about the Earth's structure, including the thickness of its crust, the location of its tectonic plates, and the size and shape of its mantle and core. This information is important for understanding the behavior of earthquakes and the potential for future earthquakes in a given area. In addition to understanding the Earth's structure, seismic waves can also be used to study earthquakes themselves. Seismologists can use the data collected by seismic monitoring stations to determine the size, location, and magnitude of an earthquake. This information is critical for understanding the impacts of earthquakes and for developing early warning systems. However, despite the benefits of seismic wave study, there are also limitations to what we can learn from these waves. Seismic waves can be affected by the Earth's structure, making it difficult to accurately interpret the data they provide. Additionally, the limited number of seismic monitoring stations in some areas of the world means that there are still many earthquakes that go undetected. It is also important to note that artificial earthquakes, or earthquakes triggered by human activity, can occur through the use of explosives. The process involves placing a controlled amount of high-powered explosives in a targeted area and detonating them. The resulting shock waves can cause the ground to shake and trigger a small earthquake. This method has been used in the past for mining operations, construction projects, and even military operations. However, it is important to note that triggering earthquakes artificially can have unintended consequences and can potentially cause significant damage to the surrounding area. It is also unethical and generally discouraged by the scientific community. Instead, efforts should be focused on understanding and predicting natural earthquakes to minimize their impact on communities. The damage caused by earthquakes. Earthquakes can cause widespread damage and disrupt entire communities. The extent of the damage depends on several factors, including the magnitude of the earthquake, the depth of the focus, the proximity to populated areas, and the quality of the building construction in the affected area. One of the most visible impacts of earthquakes is the damage to buildings and infrastructure. Earthquakes can cause buildings to collapse, roads to crack, bridges to fall, and power and communication lines to be disrupted. The damage to buildings and infrastructure can be especially severe in areas with older and poorly constructed buildings. In the most severe earthquakes, entire cities can be destroyed. For example, the magnitude 9.0 earthquake that struck Japan in 2011 caused widespread damage and resulted in the collapse of many buildings, including homes, schools, and hospitals. In addition to physical damage, earthquakes can also have significant economic impacts. Businesses can be disrupted, supply chains can be disrupted, and entire economies can be impacted by the destruction of buildings and infrastructure. For example, the earthquake that struck Haiti in 2010 had a devastating impact on the country's economy, with many businesses and homes being destroyed and the country's infrastructure being severely damaged. Earthquakes can also have a significant impact on human health. People can be injured or killed as a result of collapsing buildings, falling debris, and fires that can break out as a result of the earthquake. In addition, earthquakes can trigger landslides and tsunamis, which can also cause significant damage and loss of life. For example, the magnitude 9.1 earthquake that struck Indonesia in 2004 triggered a massive tsunami that killed over 230,000 people and caused widespread damage along the coast. Despite the significant impacts of earthquakes, it is important to note that there are steps that can be taken to reduce their impact. Building codes can be strengthened to ensure that buildings are designed and constructed to withstand earthquakes. Early warning systems can be developed to give people time to evacuate before an earthquake strikes, and disaster response plans can be developed to ensure that communities are prepared to respond quickly and effectively in the event of an earthquake. Preparing for earthquakes. Given the destructive potential of earthquakes, it is important for individuals and communities to be prepared in case an earthquake strikes. Preparing for earthquakes involves a combination of education, planning, and taking action to reduce the impact of earthquakes. One of the most important steps in preparing for earthquakes is to educate yourself and others about earthquakes, their causes, and how to respond in the event of an earthquake. This includes understanding the importance of drop, cover, and hold on during an earthquake, and knowing how to turn off utilities and evacuate buildings if necessary. It is also important to have a basic understanding of first aid and how to provide assistance to others in the event of an earthquake. Another important step in preparing for earthquakes is to develop a plan. This should include creating an emergency supply kit, developing a communication plan with family and friends, and identifying safe locations in your home and workplace. It is also important to have a plan for what to do after an earthquake, including how to evacuate and where to go for assistance. In addition to education and planning, taking action to reduce the impact of earthquakes is also important. This includes retrofitting older buildings to improve their ability to withstand earthquakes, and ensuring that new buildings are designed and constructed to withstand earthquakes. It is also important to identify and address any potential hazards in your home and workplace, such as securing heavy furniture and installing seismic switches on gas lines to prevent fires. Another important step in preparing for earthquakes is to participate in earthquake drills and simulations. These exercises help individuals and communities to practice what to do in the event of an earthquake and to identify areas for improvement in their preparedness plans. For example, the Great Shakeout, a worldwide earthquake drill held annually on the third Thursday of October, involves millions of people practicing how to respond in the event of an earthquake. Famous earthquakes in history. Throughout history, earthquakes have caused widespread damage and loss of life. Here are a few of the most famous earthquakes in history. 1. Lisbon Earthquake, 1755. On November 1, 1755, a massive earthquake struck Lisbon, Portugal, causing widespread destruction and killing as many as 100,000 people. The earthquake was followed by a tsunami and a fire that devastated the city. This earthquake is considered one of the deadliest earthquakes in history and helped to shape the field of seismology. 2. San Francisco Earthquake, 1906. On April 18, 1906, a massive earthquake struck San Francisco, California, causing widespread destruction and killing as many as 3,000 people. The earthquake is considered one of the most significant earthquakes in U.S. history, and led to the development of building codes and regulations aimed at reducing the impact of earthquakes. 3. Kobe Earthquake, 1995. On January 17, 1995, a massive earthquake struck Kobe, Japan, causing widespread destruction and killing over 6,000 people. The earthquake was one of the most destructive earthquakes in Japanese history and led to improvements in building codes and emergency response procedures. 4. Haiti Earthquake, 2010. On January 12, 2010, a massive earthquake struck Haiti, killing as many as 316,000 people and causing widespread destruction. The earthquake was one of the deadliest earthquakes in modern history and led to a massive international relief effort to provide aid to the affected populations. 5. Nepal Earthquake, 2015. On April 25, 2015, a massive earthquake struck Nepal, killing over 9,000 people and causing widespread destruction. The earthquake was one of the deadliest earthquakes in modern history and led to a massive international relief effort to provide aid to the affected populations. 6. Mexico City Earthquake, 2017. On September 19, 2017, a massive earthquake struck Mexico City, causing widespread destruction and killing over 300 people. The earthquake was one of the most destructive earthquakes in Mexican history and led to improvements in building codes and emergency response procedures. These earthquakes serve as a reminder of the destructive power of earthquakes and the importance of being prepared for earthquakes. By taking steps to prepare for earthquakes and reducing the impact of earthquakes, individuals and communities can be better equipped to respond in the event of an earthquake and reduce the impact of earthquakes on lives and communities. Therefore, earthquakes are a natural phenomenon that have had a significant impact on human societies throughout history. Understanding the causes of earthquakes, the science behind predicting earthquakes, and the damage caused by earthquakes is essential for preparing for and responding to earthquakes. Earthquakes have caused widespread destruction and loss of life, but with preparation and response efforts, we can reduce the impact of earthquakes on lives and communities. It is important to remember that earthquakes can occur at any time and in any location, and that everyone should take steps to prepare for earthquakes, such as creating an emergency preparedness kit, identifying safe places in their homes and workplaces, and familiarizing themselves with emergency response procedures. By staying informed and prepared, we can reduce the impact of earthquakes and ensure that individuals and communities are better equipped to respond in the event of an earthquake. Whether you live in a high-risk earthquake zone or not, taking the time to prepare for earthquakes is an important step in protecting yourself, your loved ones, and your community.